Here is the global handler with both blocks visible. Client fault 4xx on top, server fault 5xx underneath, and both of them are type any. Now, if both are any, how does Mule ever reach the second one? Because matching is strictly top to bottom, first match wins and the first block has a when condition that the second one does not. Order inside an error handler is not cosmetic, it is the routing logic. And if you ever want the truth about what a handler actually is, do not squint at the canvas, open the outline view. It reads it back to you as a tree, global_error_handler, error handler. Underneath it, client fault 4xx, on error continue. That is worth pausing on, because it looks like the opposite of what you would expect in a handler named for propagation, and it is correct. Here's why. This is an API. When validation fails, you do not want Mule to propagate the error up to the HTTP listener and let it generate a generic 500 with an empty body. You want to build your own JSON envelope, set your own status code, and return that. On error continue is what lets you do it. The handler produces a response, and the flow completes with it. Propagate here would throw away the envelope you just built. So when do you propagate? When something above you needs to know it failed. If this flow runs inside a transaction, propagate is what triggers the rollback continue would commit a half-finished write. If it is a batch step, propagate is what marks the record as failed so it lands in the failure set instead of silently counting as a success. If it is a subflow called by an orchestrator, propagate is what lets the orchestrator compensate. The rule is simple. Continue at the edge where you produce the response. Propagate everywhere something is still depending on you. And the same type picker exists here. Any is checked, and you can see how short the list is at this level. Any expression, stream maximum size exceeded because a global handler is not attached to a specific connector, so Studio only offers the core types, which is exactly why these two blocks route on the when expression instead of on the type. And look what is inside each block. A single flow reference, and both point at the same target error-response-builder. The 4xx path and the 5xx path share 100% of their code. The only thing that differs is the condition that chose the block. If you ever find yourself copying components between two handler blocks, this is the pattern you were missing. This is the data weave inside resolve error from catalog, and it is worth reading line by line. Line 4 builds one string key out of the error, the namespace, then a colon, then the identifier. So a validation error becomes the string app:validation. And look at the two defaults app and unknown. On some errors, particularly system-level ones, error type can be null. Without those defaults, this line throws an error inside your error handler, which is the worst place in the application to have a bug. Then the catalog. 1 row per error type, 4 facts on each row, the HTTP status, a stable machine-readable code, whether it is the client's fault, and whether the message is safe to show the caller. This is the whole idea. Your error policy is data in one place that you can read in 10 seconds. The alternative is a choice router with 15 branches spread across 4 files, and nobody can tell you what your API returns. The top rows are the caller's fault. app:validation maps to 400, code validation_error. app:business rule maps to 422, and that distinction is worth knowing. 400 means the request was malformed. 422 means it was well formed but you are not allowed to do it. Both have expose set to true, because telling someone their amount is missing leaks nothing. The next rows are your fault. Backend unavailable maps to 503, backend auth failed maps to 502, and both have expose set to false. That flag exists for a security reason. The raw description of a backend failure contains hostnames, ports, sometimes credentials and stack fragments. Return that to a public caller and you have just handed an attacker a map of your internal network. Line 17 does the lookup, and it has a default of its own. If the error type is not in the catalog, fall back to the default row, which is a 500 with a generic code. That single default is what makes this design safe. A brand new error type from a connector you added last week does not crash the handler. It comes out as a clean 500 and gets logged, and you add a row for it tomorrow. And the last block builds the output. Read the message line. If expose is true, use the error zone description with the default in case it is empty. Otherwise, return a fixed, safe sentence. The request could not be processed. Contact support with the correlation ID. Notice the comment sitting above it. Expose false never leaks internals to the caller. And notice the last line, the real detail is still captured in a field called internal, so it goes to your logs. Nothing is lost, it is just not returned. So here is what that code sits inside. 4 components in a row, each with exactly one job. Resolve error from catalog turns the error into facts. Build error response turns those facts into JSON. Set HTTP status race the status code into the same HTTP status variable the success path used. And log by severity decides how loudly to complain. If you can name each component's single responsibility in 4 words, your pipeline is right. Look at the choice at the end. It reads the client fault flag the catalog produced, and routes to 2 different loggers. Client faults go to log client fault somebody sent you a bad request. That is a warning, not an outage. Everything else goes to log server fault at error level, and that is the one you alert on. This is how you stop a customer typing a bad postcode from paging your on-call engineer at 2 in the morning. And now you can read the handler blocks properly. Client fault 4xx carries a when condition. Server fault 5xx does not, which makes it the catch-all, and which is exactly why it has to be second. Put the catch-all first and it swallows everything, and the specific block below it becomes dead code that never runs once. Studio will not warn you. Your tests will not fail. It will just quietly never work. And that is the whole point of putting it in its own file. This handler is not owned by post or flow. Every flow in the application points at it. When your security team asks you to stop returning internal messages on 500s, you change one catalog row in one file, and every endpoint in the application changes with it. Back to where errors are born. 4 raise error components, 1 per branch of the choice. Nothing here is broken, the connection is fine. The JSON parsed, data weave is happy. These errors happen because a human decided the request is not acceptable. That is what makes them useful. They arrive with the name you chose, at the moment you chose, instead of as a null pointer 4 components later. It has 2 fields that matter, and the first one is mandatory. Type. This one is app::validation. Both halves are yours to invent. App is the namespace, a short tag for your application, uppercase, and the same one across every flow you own. Validation is the identifier, the category of problem. Choose app::validation or orders::payment declined. Do not choose mule::anything, because that namespace belongs to the runtime and reusing it will collide with real types. The second field is description, and it is technically optional. Fill it in every single time. This string becomes error.description, which is what the catalog returns to the caller when expose is true, so write it as a sentence a human can act on. Customer ID is required, not validation failed, not error in field 3. The person reading it is either a developer at 2 in the morning or a customer on the phone, and neither of them can do anything with validation failed. And here is the 4th branch, with a different type. app::business_rule, description, or amount exceeds the 10,000 approval threshold. Compare that to the first one. Missing customer ID is a malformed request 400. An amount over the approval limit is a perfectly valid request that a rule refuses 422. Same component, different type, different status code, and the catalog already knows the difference. That is the loop closing. Raise a name type here, and the response is already decided over there. And the outline view gives you the whole validation contract on one screen. Validate request, choice, then each when condition with its raise error underneath, and a default at the bottom. That default branch matters. A choice with no otherwise silently passes anything that matches nothing, which means an invalid request sails straight through your validator. Always give it a default. Last piece. How does a flow actually find that handler? Open the Global Elements tab. This is every shared configuration element in the application, the configuration element itself, your global properties, the HTTP listener config, and the 2 request configs we saw earlier. One list, one place. Select the configuration element, click Edit, and there is the field that does the work, default error handler. Set it to global_error_handler. That is it. Every flow in this application that does not specify its own handler now falls back to this one automatically. You did not touch a single flow. This is the setting that turns a handler you wrote into a policy the whole application obeys. And if you want one specific flow to use it explicitly, every flow has an error handling section at the bottom of the canvas. It is collapsed and easy to miss. Expand it, and you can either drop blocks in directly or point it at a handler that already exists. Click it and the Properties panel has exactly one field. Reference. Choose global_error_handler. The flow now uses the shared handler, and not one component was copied into this file. Compare that with the alternative, the same 6 components pasted into 40 flows, and a change request that takes a week. And the outline view shows you something important here. Read it. There is an error handling node nested inside try with continue, and a second error handling node at the very bottom. At flow level, 2 handlers in one flow at 2 different depths. That is not a mistake, it is the precedence chain. And it is the thing you have to understand to predict what your application does when something fails.